So dear students, today we will see the codal provision of shear wall. So in the last lecture we have already seen the introduction of shear wall, its various types, the basic requirement of shear walls, the suitability of the shear wall in the buildings. Okay, so today we will see the analytical requirement and the codal provision of the shear wall as per IS 456 and IS 13920 1993. So the two different codes has given the requirement of structural requirement of the shear walls. Okay, so basically the IS 456 is a generalized code for all the building structure. So here we can see the generalized procedure and generalized steps for the analysis of the shear wall, and according to that we can design the shear wall for the non-seismic region. Whereas if you refer the IS 13920, in that code the design and the analytical requirement is given in the various clause as per the ductile detailing. So in as per the IS 13920, we can preferably design the shear wall as more ductile than as per IS 456. Okay, so let us see step by step. First of all, we will see the codal provision, the main and the basic codal provision of the generalized requirement of the shear wall as per IS 456. So if you refer IS 456 at page number 61, so there you will get the clause of 32. Under 32.1 you can see that the reinforced concrete wall is subjected to the direct compression, and a combined flexure and direct compression should be designed in accordance with the section 5 of annexure B, provided the vertical reinforcement is provided in each face. So the braced wall subjected to only the vertical compression may be designed as per the empirical procedure given in 32.2. So the minimum thickness of the wall as per IS 456 should be restricted as a or can be taken as 100 mm. Okay, so this is the main requirement of the wall as per IS 456. Now guideline or design of the wall subjected to horizontal and vertical loads. So let us see. So first of all, what are the basic requirement of the brace wall? Let us see that. So walls shall be assumed to be braced if they are laterally supported by the structure in the following apply. So first of all, the wall or the vertical brace element are arranged in the two directions so as to provide the lateral stability to the structure as a whole. This is the most important part. Second is the lateral force are resisted by the shear in plane of this wall or by the brace element. Then the floor and roof system are designed to transfer the lateral forces. Okay. Then the connection between the walls and lateral supports are designed to resist the horizontal forces, not less than the simple static reaction to the total applied horizontal force at the level of the lateral support. Then the 2.5% of the total vertical load that the wall is designed to carry the level of the lateral support. So these are the basic requirement of the brace wall. Okay, then the eccentricity of the vertical loads. Okay, so the design of the wall shall be taken into account of the actual eccentricity of the vertical force subjected to the minimum value of 0.05 t. So you can allow, as per the IS 456, we can allow the eccentricity of the vertical load up to 0.05 times t. T is the thickness of wall. Then the vertical load transmitted to the wall by the discontinuous concrete floor or the roof shall be assumed to act at 1/3 of the depth of the bearing area. So this point you must remember that. Then where there is an in situ concrete floor is there, then in situ concrete floor, the continuous over the wall, the load shall be assumed to act at the center of the wall. So these are the primary requirement of the load transfer. Then the resultant eccentricity of the total vertical load on the brace wall at any levels between the horizontal support and shall be calculated on the assumption of that the resultant eccentricity of all the vertical load above the upper support is 0. So this point you must remember. Then what are the height criteria? Then the maximum height to the thickness, that is h we by t shall not be exceed 30. So this is the criteria to decide the maximum effective height of the wall, okay, of the shear wall. Then the effective height. So how the effective height is calculated, what are the parameters on the basis of which the effective height can be decided is mentioned here. First of all, where the restraint against the rotation at both the end by the floors is equal to 0.075 times h. Then intersection of the wall or similar member, whichever is less, is 0.75 times L1. Then where is not restrained against the rotation at both the end, then the floor should be equal to 1.0 times HW. Okay. Then intersection of the wall or the similar member, whichever is lesser, is 1 times L1. So what is HW is the unsupported height of the wall, and L1 is the horizontal distance of between the center of the wall. Then next step is the calculation of design axial strength of the wall. So it can be calculated by this formula: PUW is equal to 0.3 times T minus 1.2 E minus 2 EA FCK. So where T is the thickness, E is the eccentricity of load, then EA is nothing but an additional eccentricity which is formed due to the slenderness effect of the taken as HWE divided by 2500 T. Okay. Then if the wall is designed for the combined horizontal and vertical forces, then in that case what are the parameters? Let us see that the wall subjected to horizontal force perpendicular to the wall or for which the design axial load is not exceed 0.04 times FCKAG shall be designed as a slab in accordance with the appropriate provisions. Okay. Then how to design the shear? So let us see that the critical section of the shear can be calculated at the distance from the base is 0.5 times LW to 0.5 times HW, whichever is less. Then nominal shear stress can be calculated. This is the same formula that we are already using in our slab design, beam design. Tau VW is equal to VU by TW. Okay, instead of B, here we are using T because here the thickness of the wall is important. Then VU is the shear force, we know that. T is the thickness of wall, and D here we have to consider D very carefully. D has to be considered as 0.8 times LW, where LW is the length of the wall. Then under no circumstances shall the nominal shear stress should be wall of the tau VW in the wall should exceed 0.17 times FCK in the limit state method and 0.12 times FCK for working stress. So whatever the method of design you are adopted, so accordingly you can put your value of the tau VW. Okay. Then next is the design shear strength of concrete. So here tau CW without shear reinforcement can be taken as for HW by LW. This is the first criteria. If it is less than 0.1, then the formula is applicable like this. Okay. Then if for HW by LW is greater than 1, then in that case tau CW, the formula will be like this. So this formula can be utilized as per the conditions. Okay, whatever the condition here given. Okay. Then the design of shear reinforcement. The shear reinforcement shall be provided to carry the shear force equal to VU minus tau CWT 0.8 LW. So in case of working stress, VU can be replaced by V, and whereas the strength of the shear reinforcement can be calculated as per 40.4 and B 5.4. Okay. So AV is equal to PW 0.8 LWT. Okay, where PW is determined by using the following equation like this. Okay. Then next is the minimum requirement of reinforcement in the wall. Okay, so reinforcement, the minimum reinforcement of the wall shall be provided as below. The first criteria is the minimum ratio of the vertical reinforcement to the gross concrete shall be, if it is 0.0012 head for the deformed bar not larger than 16 mm in diameter with the characteristic strength is 415. Whereas second is 0.0015 for other types of bar and 0.0012 for welded wire work. So we are interested in this one. First case. Okay. Then the vertical reinforcement requirement is like that. If it is like if it is shall be spaced not farther apart than 3 times the wall thickness, not more than 450 mm, and the minimum ratio of the horizontal reinforcement to the gross shall be 0.002 for the deform bar, not larger than 16 mm in diameter. So this requirement is important. Okay, other two requirements are applicable for the different cases. Okay, the welded wire is not applicable, so we are interested in these two. Okay, then the horizontal reinforcement shall be spaced not farther apart than 3 times the wall thickness. Okay, then the wall having the thickness more than 200 mm. Okay, so this clause is very important. So whatever we have seen about this, these are the requirement of the wall if you are considering the wall thickness in between 100 to 200. Okay, if you consider the wall thickness as 100 mm or 150 mm, in that case the above procedure is applicable. But here the special requirement is there if you are considering, because of the high loading, the thickness is 200 mm, more than 200 mm. Then in that case what we have to do, the vertical and horizontal reinforcement shall be provided in 2 grids, one near the each face of the wall. So the vertical reinforcement need not to be enclosed by transfer reinforcement for the as like a column, and if the vertical reinforcement is not greater than 0.1 times the gross sectional area, or where the vertical reinforcement is not required by the compression. So these are the requirement as per the IS 456. Okay, so you must understand this clause, okay, in order to enhance your knowledge about the analytical procedure of the shear wall. Okay, because these clause required for the design of shear wall. Now next we will see the what are the requirement and the procedure as per IS 13920, because we are dealing with the earthquake forces. So as far as the earthquake factor comes into picture, so the normal reinforcement is not very much effective. So in that case we require the ductile structure. So for enhancing the ductility in the structure, we required IS 13920, because IS 13920 is a special code which is basically focused on the ductile detailing. Okay, so let us see the requirement of IS 13920. So here in as per IS 13920 1993, if you see the page number, I think 12, yes, on page number 12, these are the some requirement which are given. So let us see. So the requirement of the section applied to the shear wall, which is a part of a lateral force resisting system, and the thickness of any part of the wall shall be preferably not less than 150. So you must understand that here the minimum requirement of wall is 150 mm, whereas in case of 456 it was 100 mm. Okay, but if you are designing the wall as per your ductile detailing, then you must provide at least 150 mm thickness in the wall. Okay, then the effective flange width to be used in the design of the flange wall shall be assumed to extend beyond the face of the wave for the distance which shall be similar to smaller of half the distance of the adjacent shear wall, and second one is a 1/10 of the total wall height. So these two parameters you must consider. Then the shear wall shall be provided with the reinforcement in the longitudinal as well as a transfer direction in a plane of the wall, and the minimum reinforcement ratio shall be 0.0025 of the gross area in each direction, and this reinforcement shall be distributed uniformly across the cross section of the wall. Then if the factored shear stress in the wall is exceed 0.25 under root of FCK, that is a standard criteria, or if the wall thickness is exceed 200 mm, then the reinforcement shall be provided in 2 curtain, and each are having a bar running in a longitudinal as well as a transfer direction. Then the diameter of the bar used in the part of the wall shall not exceed the 1/10 of the thickness of that part, and then maximum spacing of the reinforcement in either direction shall not be exceed the smaller of LW by 5 or 32 TW and 450 mm, whichever is, where LW is the horizontal length of the wall and TW is the thickness of the wall. Then let us see what are the shear reinforcement requirement. So here also the formula is similar. Tau V is equal to VU by TW dW. Okay, we know the nomenclature of this formula very well. Tau W is the nominal shear stress, VU is the factored shear force, TW is the thickness of wave, and dW is the effective depth. Here also for depth calculation, here is considering the value as 0.8 times LW, just similar to that of IS 456 we have seen. Okay, then the design shear strength of the concrete tau c shall be calculated as per table number 13 of IS 456. So the similar procedure we have to adopt as per IS 456. Then the similar nominal shear stress in the wall tau v shall not exceed tau c max. Okay, then tau v is not less than tau c, the shear reinforcement shall be provided in accordance with 9.1.4 and 9.155. These are the clauses which are applicable. Then tau v is greater than tau c, then area of the horizontal shear reinforcement, that is AB, to be provided within the vertical spacing. The formula for spacing is exactly similar to IS 456. VUS is equal to 0.87 FY AH dW by SV. Okay, then VUS, we know the calculation of VUS, VU minus tau c TW dW. This is similar to IS 456 formula. Okay, then the vertical reinforcement that is uniformly distributed in the wall shall not be less than the horizontal reinforcement calculated as per 9.2.5. Then the flexural strength. Then the moment resistance MUV of the wall section may be calculated as per the column subjected to combined bending and axial force. Then the moment of resistance of slender rectangular shear wall with the uniform distributed vertical reinforcement is given in annexure 1. So that procedure you can adopt for the design of flexion. Then the crack flexural strength of the wall section should be greater than the uncracked section. This is a similar one. Then in the wall that do not have a boundary element, the vertical reinforcement shall be concentrated at the end of the wall, and each concentration shall be consist of minimum of 4 bars of 12 mm diameter arranged in at least 2 layers. Then the boundary elements. So this is the new additional reinforcement part in the shear wall because of the ductility provision. So let us see what are the boundary wall provisions. So boundary wall is nothing but a portion that are along the wall edge that are strengthened by the longitudinal and transfer reinforcement, and though they may have a same thickness as that of a wall wave, and it is disadvantageous to provide them with a greater thickness. Okay, so these boundary elements are provided at the either end of the walls. Then where the extreme fiber compressive stress in the wall due to the factored gravity load plus the factored earthquake force exceed 0.2 FCK, the boundary element shall be provided. So this is the main criteria by which you can decide whether you have to provide the boundary element or not, or otherwise the simple shear wall is enough to resist the laterals or vertical loads. Okay, then the boundary element may be discontinued where the calculated compressive stress become less than 0.15 FCK, and the compressive stress shall be calculated using the linearly elastic model and the cross section property, and the boundary element shall be have adequate axial load carrying capacity, assuming the short column acting so it's enable it to carry an axial compression equal to sum of the factored gravity load on its and the additional compressive load induced by the seismic forces. So by the formula we can easily calculate the factor design force. So mu minus muv divided by cu, you will get the answer as a factor design moment on entire wall section, and MUV as a moment of resistance provided by the distributed vertical load, and CW is the center to center distance. Okay, so these are the provisions which are applicable for the boundary wall. Then next is, if the gravity load added to strength of the wall, then the load factor can be taken as 0.8, and the percentage of the reinforcement, vertical reinforcement in the boundary element shall not be less than 0.8% or shall not be greater than 6%. So this is similar to the design of column. Okay, then in order to avoid the conjunction, the practical upper limit would be 4%. So boundary element where the required as per 9.4.1 shall be provided throughout their height with the special confining reinforcement, and the boundary element need not to be provided if the entire wall section is provided with special confinement. Then the special requirement of the coupled shear wall. Let us see that what are the requirements. So coupled shear wall are generally provided by shall be connected by the ductile coupling beams. So if the earthquake is induced in the shear stress, then the coupling beam should not exceed 0.1 times LB under root FCK by D, where LB is the LS is the clear span of the coupling beam, and D is the overall width of them. So this is the general requirement of coupled shear wall. So you can go for this and you can see that. Then more over we can skip this part and we will go for the opening in the wall. So if someone is interested in designing the shear wall with opening, so what are the basic requirements? Let us see that. So as per the clause number 9.6, the shear strength of the wall with the opening should be checked along with the critical plane that pass through the opening. So the reinforcement shall be provided at the edge of the opening in the wall, and the area of the vertical and horizontal bars should be such that it is equal to that of the respective interrupted bars, and the vertical bar should extend to the full story height, and the horizontal bar should be provided with the development length in tension beyond the side of the opening. Then the discontinuous wall, the column supported discontinuous wall shall be provided with the special confining reinforcement. Then the construction joints are provision is there, the development of the splice is there. Okay, so this is the basic formula. By using, one can easily calculate the moment of resistance of a walls. So this is the formula. So it is similar to the formula which is applicable for the design of a compression member as per IS 456. So if you remember the clause of IS 456, the design of the compression member, that is a T-beam or flange beam. So in that case there are certain criterias are there. So based on that one can decide the T-beam or the L-beam. Okay, so similar to that here also there is a moment of resistance formula is there. So by using these conditions we can adopt one formula. So here there are, I think, two formulas are available. So based on that we can go for the various condition, and we can put the various values as per our requirement, and based on that we can calculate the moment of resistance of a rectangular walls. Okay, so these are the requirement, you can go to that. Okay, so this is the basic analytical procedure by which you can design the shear wall as per IS 13920. Okay, so today we have seen the basic of the design of shear wall as per the two different codes. Okay, because both the codes has given their own requirement for the design of shear wall. Okay, so you must understand that IS 13920 is focusing on the ductile detailing. So here the procedure is somewhat tedious than that of IS 456. Okay, so we will see one design example of IS design of shear wall, so that your theoretical concept related to this different codal provision of design of shear wall will be more clear. Okay, so we will see this numerical of the design of shear wall in our next lecture. Okay, so thank you for your kind attention. Thank you.